we're going to start off Chapter 12, three-dimensional figures and surface area, with just talking about some of the basic parts and some vocabulary that might help you out, because it may appear on the STAR test, it may not. So we want to cover our bases just in case. All right, our first word is a polyhedron or polyhedra, and these are solids with all flat faces that enclose a single region of space. So to draw some examples of polyhedrons, you could have a rectangular prism, you could have a pyramid, you could have, let's see, let's try a triangular prism. What you don't see are cones or cylinders. These are not polyhedrons or spheres either. And the reason why is because they are rounded. These all have non-circular faces, which means they are polyhedrons. These have circular faces. They are not considered polyhedrons. All right. So now then, a face is a word we need to talk about. The faces of a space figure are the flat sides of the figure. So I'm going to draw a cube. Nice little cube here. It's a little warped, but it'll work. Okay? And this front square would be considered a face. Would be considered a face, just like this side here, the back, the side, the bottom, the top. Those are your faces. Those are your flat surfaces. Now, an edge. An edge would be where the faces meet. It's like a line. So I'm going to draw another cube. This one not as warped as the previous. This is an edge. This is an edge. This is an edge. This is an edge. All of these are edges. They're all over the place. Okay? And so if we were to look at counting these up, a cube has 4 edges on top, 4 on its side, and 4 on the bottom. So there are 12 in all in a cube. And the number of faces that a cube has is 6. The front, the back, left, right. All right, now then, a vertex. A vertex, this is where your corners are, the sharp points, where you have edges that come together. So the vertices are the corners or the points of intersection of 3 edges. So we'll draw another cube. All right, and each one of these little corners, here, 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 and here, these are all a vertex. And so if we were to number of vertices in a cube, you would have 8. 4 on top, 4 on bottom. 8 in all. All right? Now then, the base. Around the stairs on the other side of the hall. Okay, so the base is are the 2 ends of a prism or a cylinder, or it is the bottom of a pyramid or cone. Now, I know we were talking about polyhedrons earlier, and we were saying that cones and cylinders are not polyhedrons. This is true, but they do still have bases. All right, so you would have, let's see, a cylinder would have 2 bases right here. Those are your bases. If you had a pyramid, this is a horrible pyramid, but it'll work. This would be your base down here. If you had a prism, we'll draw a long, tall, skinny prism. Okay, this would be a base, and this would be a base here. All right, so they are the two ends of a prism or cylinder, or it is the bottom of a pyramid or cone. Now then, a pyramid is a polyhedron that has all faces except one intersecting at one point. So there we go right there. All of the faces all the way around intersect at a point except one, the base. And a prism is a polyhedron with two congruent faces that are polygons contained in parallel planes. Sounds like a very formal definition, but basically what we're saying is we've got two ends, booyah, booyah. Everything in between is a rectangle. All right? And you name a prism by its bases, and you do need to know that. You name a prism by the shape of the bases. You can have this one, if this was a square, that could be a square prism. If this was a triangle, it would be a triangular prism. We can have a pentagon, and it'd be a pentagonal prism. So that's how we define the names of our prisms. All right, now, there's a little rule called Euler's theorem in 12.1, and it's a little a little formula that will help you determine maybe how many faces, vertices, or edges that a particular shape has. And it's kind of a quick way to help you out. And what it is, it's the number of faces plus the number of vertices is equal to the number of edges plus 2. So if you're trying to count these up and you have a very big type of polyhedron with a whole lot of faces and edges and such, this would be something that could help you out in trying to solve those. All right, then you have regular polyhedron. Oops, let's see, we're missing an L there. This is a polyhedron whose faces are all congruent regular polygons. Okay, so if we had an equilateral triangle, okay, and then every face on this was also an equilateral triangle. This is very hard to determine, but every face would be the same. Every face is an equilateral triangle. Okay, and you can do, they could be different shapes and such. Convex polyhedrons, these are polyhedrons such that any 2 points on its surface can be connected by a line segment that lies entirely inside or on the polyhedron. We're not going to talk about these too much. This is in the book if you want to look at it some more. And I really do recommend you reading 12.1 because it's got some information in there that's kind of good to know. Some of it you've heard of and some of it you haven't. The last one, a cross-section. I could see them having a star question over this where, let's see, if we're going to have let's do a triangular prism here. Okay. This is something like if I had a plane that intersected this, so in other words, it cut this, it went straight through it, it would cut this in a way so that it would create another triangular shape in there. This is kind of hard to draw. There's good pictures in the book. I'd recommend you looking at it. It's a very simple concept. It's just very hard to draw and get the idea of it. Okay, now then, those are some basics. Now we're going to go on to finding actual surface area. And we're going to start off with prisms and cylinders. And you're going to notice, Art, that the formulas for these are the same. Okay, however, on some of the form, we're going to see that they're the same, even though the shapes of them are not the same. So we got to look and understand what the different letters and variables actually mean and represent. On this particular one, for surface area, the P stands for perimeter, and C stands for the circumference. So if we're looking at a cylinder, we're going to use C, but if we're looking at a prism, we're going to use P. Capital B is the area of the base. Okay, when you have a capital B, you've got to find area. A lowercase b is just the line, but a capital B is the area of the base of that figure. This is huge. And H is your height. So it's the height of a prism or a cylinder, it's always the distance between the two bases. So if you're going to look at this triangular prism, this triangle and the triangle on the other side, those are your bases. Your height would be 10. That's the distance between them. And on this cylinder, even though it's laying down, the base are the circles. You've got a circle here and a circle here. 12 inches is the distance between those two circles. That is your height. Even though it's laying down, that's the distance between the two bases. So these are the formulas you're going to use. For a prism, if you're going to find the lateral surface area, and keep in mind lateral, that means the part, everything except the bases. You're going to take perimeter times the height, because your perimeter is each one of these sides, and the height is the other side to each of those rectangles. So you've got a 14 by 10 here, a 14 by 10 here, and a 14 by 10 here. You can find each one individually, or just plug the numbers into the formula and it's a little bit quicker. Then your total surface area is your lateral surface area plus your two bases. So that means plus the area of both triangles. And on a cylinder, your surface area is 2 pi RH, R being the radius of the circle, H being the height. Now, this part of the formula right here is circumference. So you're finding the circumference of this circle, and you're multiplying it times the height, because when you do that, you're actually finding the area of this part. If you were to split a cylinder open and unfold it, it would be a rectangle, and this circumference would actually be the length of it, and this height here would be the height. Now, the total surface area is the lateral surface area plus 2 pi RH, and the 2 pi RH, pi r squared. The pi r squared is area of a circle, and so you're finding the area of this circle, and you're doubling it because you've got the area of this circle over here. So you're adding the two areas of the bases to the area of the lateral portion. All right, now then to practice those. Regular triangular prism, it says find the perimeter of the base. That would be 14 times 3, which is 42 meters. And then find the surface area lateral. That's P times H, which is 42 times 10. So that would be 420 meters squared. Find the area of the base. Okay, the area of this base, you're going to have to do a little work involved in there, because we've got a triangle, and base times height divided by 2 is the area of a triangle. So we're going to have to find the height of it. So this is an equilateral triangle, which means when I draw my height, it's a 30, 60, 90. All right, so if this portion of the triangle is 7, then the height is 7 square roots of 3. All right, so to find the area of the base, that would be 7 square roots of 3 times 14 divided by 2. So I'm going to go ahead and divide 14 by 2 and get 7. And then 7 times 7 square roots of 3 would be 49 square roots of 3 meters squared. And then find the surface area total. Okay, now we're looking back at this formula where we've got perimeter, which is 42, times the height, which is 10, plus the two bases, 2 times 49 square roots of 3. All right, and this, we already found it was 420, so we could have taken a shortcut there. So basically, we've got 420 plus 2 times 49 square roots of 3. And I'm going to put my double parentheses there and add it up, and we get 589.7. 589.7 meters squared. All right, so now then, a cylinder. A cylinder, to find the circumference is 2 pi r. And since r is 4, we're going to go 2 pi 4. So that's 8 pi, or 25.1 inches. All right, find the surface area lateral. Lateral surface area, our formula is 2 pi r. We're going to have 2 pi 4 12, multiplying all of those together. So 4 times 12 is 48, times 2 is 96, so that would be 96 pi, which is 1.6 inches squared. Now, area of the base. The base is a circle. Area formula for a circle, which is pi r squared. So we've got pi times 4 squared. That's 16 pi, or 50.3 inches squared. All right, now we're going to be using these in our formula to find total surface area. 2 pi RH, well, 2 pi RH is this right here, so 301.6 plus 2 circle areas. One circle area was 50.3, so we're going to plug that in. We've got 301.6 plus 2 times 50.3. You get 402.2 inches squared. All right, so that is your surface area for prisms and cylinders. Now, pyramids and cones. I'm going to go through these a little bit faster. All right, still we have P for perimeter, C for circumference, B, capital B for the area of the base, H for the height, but now we have this little letter, this cursive L. This is the slant height for both pyramids and cones. And the reason why we have slant height is because in a cone, you've got the length of this right here. This is called slant height, and in a pyramid, it's the same way. This is your slant height, okay, which is different from the actual height. The actual height is always perpendicular, but slant height is a slant. All right, so when you see that, this is the perimeter times the slant height divided by 2. That would give you your lateral surface area for a pyramid, plus 1b would give you total surface area, because if you remember, a pyramid only has one base, not two bases. And then in a cone, if you're going to find lateral surface area, the distance around, it's pi times the radius times the slant height. And in the total is your lateral surface area plus pi r squared. So it's the lateral plus the area of the base. Now there is another formula that's used. I think these are easier just because they're more common. They look a little bit easier to use. All right, so now then we're going to practice those. So we've got a square pyramid. Find the perimeter of the base. That would be 15 times 4, because it's a square bottom, so all sides are 15. So that would be 60 centimeters. Find the slant height. Okay, the slant height in this situation is the height of this face. This is a triangle right here, and its altitude is the slant height of the pyramid. That can be very easily confused. That can be very confusing sometimes, so be very careful about that. That the height of the face is the slant height of the pyramid. Find the surface area lateral. Okay, so our formula for that is perimeter times the slant height divided by 2. So I've got 60 times 9 divided by 2. Or in this case, 30 times 9, which gives me 270 centimeters squared. The area of the base. The area of the base, the figure is a square, so that would be 15 squared, or 225 centimeters squared. So now, find the surface area total. We add up the lateral plus the base, and then that would give us 495 centimeters squared. Now we've got a cone. We got to round to the nearest tenths place. We're going to use pi. Alright, so we're going to find the circumference. And the circumference of this circle, the formula is 2 pi r. R is 4, so 2 pi 4, which is 8 pi, or 25.1. And this would be meters. The slant height, that's this right here. That is 10 meters. Find the surface area lateral. Okay, so our formula for lateral surface area is pi r L. So that would be 40 pi, or 125.7 meters squared. Find the area of the base. The base is the flat face right here. It's a circle. So since it's a circle, to find the area of it, it's pi r squared. So pi 4 squared, which is 16 pi, or 50.3 meters squared. So find the surface area total. Take your lateral plus your base, and you would get 176 meters squared. Okay, now last but not least, we have a sphere. Alright, this one is a little different looking. It's the surface area of a sphere is 4 pi r squared. Now, a sphere has a radius. It goes from the center of the sphere, of whatever the sphere is, to the edge. That's your radius. And so you've got a numerous number of radii throughout this whole thing. Alright, we also have a diameter, and the diameter goes all the way across. Alright, and it has multiple diameters. They go every direction. Now, what else you have here is a circumference, which is also called your great circle. There are numerous numbers of great circles, but if you think about this being the Earth and this being the equator, that serves as a great circle. Alright, and the great circle cuts the sphere in half. So if you ever have half a sphere, you would have this surface area, and then you would cut it in half, and you would get the top dome. Alright, now then, so all we need is the radius. So our formula, 4 pi, and r is 3.5, and that's what we're squaring. So we've got 4 pi 3.5 squared, and we put in the calculator just as that, you would get 153.9 inches squared. Okay, this next one, you're given the diameter, so the radius would be half of that, 2.1. So we've got 4 pi 2.1 squared. So 4 pi 2.1 squared, and you have 55.4, and in this case feet squared. Alright, now the only other tricks that might happen, and like I said, is if you cut this sphere in half, alright, you would divide this by 2. However, you will have a base on the bottom that is a circle in this situation, and you may have to find the surface area of that, and then in that case you would use this formula, divide it in half to get the dome part, and then find the area of the circle and add it to that. Those are some things that you might see in some of your problem solving. Thank you.